We're going to examine the Doppler shift of a moving sound source, but first we're going to determine the frequency of a stationary sound source using the same frequency. First we're going to start by capturing the sound, AudioTime plus, and the sound. We'll capture it. That's probably enough of that. And then we'll first run a Fourier transform on it to determine the dominant frequency, again, of the stationary sound source. And you see that it's 1838 is the dominant frequency. And now we'll look at the spectrum using AudioSpectrum, which produces a spectrum that we can then zoom in and examine different parts of it. So I'll have to get it positioned where we can see it. It's way down there. And it's very, very, very tightly focused. You can see all the frequencies are right around the area of the dominant frequency. So we can look, we see that the power of those frequencies is relatively small. So now we know that the dominant frequency of the stationary sound source is 1838, and now we can examine the moving sound source and examine the Doppler shift of that. This is the sound source while it's moving. This is what the recording looks like of the sound source. Now we'll play it. And we'll analyze it. And now the spectrum shows us that where before it was very tightly centered around 1838, now it's on both sides and it's spread out. On the left side we have the recessional frequency. It's a lower frequency of the moving object as it moves away from the microphone. And on the right side we have a higher frequency. That's the approaching frequency of the moving object. So that's it using AudioTime Plus and AudioSpectrum.